Hi and welcome. In today's video, I will create a simple sliding puzzle game using Godot Engine 4.0. I have created a new project, giving it a size of 1000 by 1000 pixels, and I configure the stretch mode to viewport. Then I created a new scene 2D. In this occasion, I changed the type of the node and set it as Area 2D. Then I renamed the scene. Next, I added a collision shape 2D to the main scene. Assigned it a rectangle shape 2D and gave it a size of 1000 by 1000 pixels so it covers the whole game area. I changed the position of the collision shape to be centered. With the size of our window, that would mean setting the X and Y values to 500 pixels. It is important that our main scene is clickable, as that would receive the input from the mouse. Then I started adding images that I created for the tiles. I created the first tile and assigned it the corresponding image. The tiles are 250 by 250 pixels in size. To have them in the right place, we have to discount half of their size, so for the first tile, the X and the Y positions would then be at 125 pixels. Then I created duplicates of the first tile, one for each of the 16 that we need to cover. With each new tile, I changed the image associated it and its coordinates. For the first row, I left unchanged the Y coordinate value and added 250 to the X value in each step, so the tiles would be at 125, 375, 625 and 875 pixels. The same would apply for the rest of the rows, so when the moment comes, the Y coordinate of the tiles would have to be assigned the same values. So the final tile, which would be the empty position, would be located at the coordinates 875x and 875y. We can now execute a test run of the game and check that it renders everything in place. Next, I will be adding the functionality to the game. This will be included in a new script that I will attach to the main scene. When the game loads, I wanted to call a function called newGame that will initialize the board. For now, I will add a pass method, so it doesn't throw any errors while we work with the rest of the script. To control the position of the tiles, I am going to use a couple of arrays, so I initialize both as empty arrays. Then in the start game function, I will set the value of the recall tiles to include the references to all the tiles of the board. For now, each tile is going to be in the position that corresponds them based on their number. Then I am going to create a copy of the array and call the new one solved. We will use this new array to validate if the puzzle has been solved after each new movement of the tiles. Now I'm going to add a new input event function, so we could detect when the mouse button has been clicked. The information from the event will be stored in a new variable called mouse. Now, in the process function, we will check if the mouse button pressed was the left one, and we'll also check that there is a mouse event, so the variable mouse must be true. I changed the initial status of the variable to false, so the condition is only met after the user clicked the mouse button. To do some test, I added a call to print the mouse position when the button is pressed. This will print in the output window the values for the x and y coordinates. But as you can see, rather than just printing the values once, it is doing it multiple times. So I am going to create a copy of the variable mouse, which I will use for the checks. Then I can set the mouse variable to false, so only 1 point coordinates are going to be printed. To know which tile is on the position where the mouse button has been pressed, I am going to add 2 new variables called rows and cols. Each one is going to be an integer value, resulting from dividing each of the x and y coordinates by the size of the tile. The rows and columns should be obtained from the copy of the mouse variable we created earlier. We can do some test printing the position of the tile that was clicked, but instead of the X and Y coordinates, we will print the number of column and row. Then I will use those values to calculate the position of the tile in the array. This will be the result of multiplying the number of the row by 4 and add them the number of the column. We can now execute another call to print and get the name of the tile that is in the current position. Now I am going to add a function to check if the tile we are clicking on is next to the empty space. Only if this is true, we could move the tile. The best way I have found to detect the proximity of the empty space is by dividing the board in 4 groups. If the tile is in a column smaller than 3, it means it has other tiles to its right. If it is in a column bigger than 0, it means it has other tiles to its left. The same applies for the number of rows and the tiles above and below the current position. In the new function called checkNeighbor, I am going to add 2 Boolean variables, one to check if a box next to our selected tile is empty, and another called done, which I will use to track if the 4 steps have been completed. Then I will add the logic for checking if the tile is in one of the first 3 rows. If that is the case, I will check the tile position below it by adding 250 pixels to the current Y coordinate. Next, I will set the empty value to the tile below and will subtract again the 250 pixels from the Y coordinate. Otherwise, I would be affecting the following checks. This requires a new function that I am going to call findEmpty. This will receive 2 parameters. One is going to be the position in the array of the selected tile. The other is the position that we want to check. Now I'm going to repeat the process for the rest of the checks we want to perform. In each step I will add 250 pixels to the relevant coordinate. Check the tile and restore the coordinate's previous value. In the function called findEmpty, I am now going to define 2 new variables to calculate the column and row of the tile we want to check. This is done by dividing by 250 each of the coordinates of the tile. Then the new position would be the result of multiplying the number of rows by 4 and adding the number of the column. With that, we can now check if the tile in the new position is the one called tile 16, in which case it would mean the position is empty, and we can proceed to move the selected tile into it. Now we need a new function to swap the position of two tiles. This will be used both to move the selected tile into the empty position, but also to change the position of any two given tiles. We will use this later to shuffle the board at the start of a new game. The new function will receive two parameters that will define the position in the array of the tiles that we want to swap. For the swap tile function, we are going to need a temporary variable to store the position of one of the tiles while we do the change. We will set this to the position of what we call the source tile. Then we will change the position of the source tile to be that of the destination tile. Finally, the position of what was the destination tile will be set to the value stored in the temporary variable. Next, I will add a call to check neighbor from inside the process function. When I tested it, it wasn't working 100%. The tile moved to the empty position, but when clicked again, it gave an error. This was because I had a typo in the check neighbor function, and I was not subtracting the 250 pixels from some of the values to restore them to the original. Now we need to add a function to know if the puzzle has been solved. To do a quick implementation, I am just going to print some text in the output box. I will change this in a future version of the game that you can see in my next video. For now, we are just going to check if the order of the tiles in the array called tiles is the same as in the array called solve that we created at the beginning. Now I'm going to create a function to shuffle the board. I could randomly change the position of the tiles, but I am not sure this would result in having puzzles that are impossible to solve. Instead, I am going to select random tiles and check if one of them is empty. If so, I will swap their positions. Repeating this many times will give us a puzzle that is sufficiently scrambled to avoid being too easy, while making sure it was generated with only valid moves, so it should always be possible to solve it. After some tests, I found that it wasn't working as expected. To mitigate it, I will create a new variable to track the previous position, so we do not get back instantly to the previous state. I will add a check into the if statement, so it also ensures the tile selected is not the same one. Now it looks a little bit better, but still not good enough. Even with a moderate number of repetitions, it is still not much different than the original state. So I'm going to add another variable to store the second previous position. Then, in the if statement, we'll check that the new tile isn't one of the previous two movements. Now it works much better, and you can see that the positions of the tiles are a little bit more random. After some more testing, I finally set the number of repetitions to 1000. This is no perfect by any means, but the board gets scrambled enough. As I said previously, my next video will cover some improvements to this game, like keeping a counter of the number of moves that took to solve the puzzle, and making it more interesting by using a picture rather than numbers. For now, we have a playable version of the game. As always, you can find a link to the full code and resources of this game in the description of the video. I hope you enjoyed this video, and we'll see you soon in the next one that will cover some improvements to this game. Thanks for watching.